Hello, and welcome to this new installment of ClueCon Weekly. I'm Luca Pradovera. I'll be your host for this episode. And here with me is Tsahi Levent-Levi, our friend from testRTC and bloggeek.com and many other endeavors, and is a WebRTC expert. And we know him from many of his blog posts and writings about performance and performance measuring, etc. And I'd like to ask him to help us understand how people can get their WebRTC applications to work better, keep them monitored, make the right choices, and avoid the worst pitfalls so your users can have the best experience. So welcome, Tsahi, and thank you for joining us.
Thank you, Luca.
So would you like to tell us a bit about yourself to start?
Sure. So I've got like two hats on my head most of the time, besides my family life and whatever. One is the testRTC hat, which unfortunately there I'm the CEO. I didn't want to, but that's life, and the co-founder in the company. There we do testing, monitoring, and support. We've got a software as a service platform that makes it easier for developers to use that for their own WebRTC applications. My other hat is the one of Blog Geek Me, where I write about WebRTC. I do consulting for companies around, architecture, roadmap, or marketing, as well as courses that I have there and workshops that I do throughout the year.
Oh, great. So that's two very interesting hats at the same time.
Mm-hmm.
So going into your testRTC part, and then we'll go over the BlockJig part first later. What is the so say I have just built a WebRTC application. Let's not concern ourselves with the platform itself. I will really recommend using FreeSwitch, because I like FreeSwitch and I've been working with it for a long time, or Janus, which I'm also a big fan of. And say it's working. So I have my 10 or 20 people joining every day. Now the fun part starts, because tomorrow marketing is starting to pump $1,000 a day into AdWords. What happens when those $1,000 turn into 10,000 users and my servers go down? And how do I avoid that?
So you said the answer. Things are going to crash and fail. There are a lot of things that happen even before that. Okay, I built an application. The application is working. Now, working is a kind of, it worked on my machine.
Yeah.
That's the biggest problem with WebRTC, because the first thing you do is you peek at what happens in AppRTC. You see that they have a stan server there called stan.google.com. You say, well, Google, what can ever go wrong? You copy paste it into your code, it works, and everyone is happy. There are two problems with doing that. The first one is that stan server is not yours and you don't get it with an SLA. It always sometimes not there because of whatever. It fails as well, but you can't go and complain. And the second thing, there are no turn servers there. So it works for you, but it might not really work for your customers because they are behind, a firewall or an ad device or whatever. So in these cases, you need to now add a turn server. Now with WebRTC, you have a sync signaling server, you've got the turn servers, and then you might have media servers most of the time. Each one of them has its own scaling requirements. Some of them are on CPUs, scale based on CPUs. Some of them scale on network. Some of them are like, there's no scaling issues like signaling up until the point that it just bursts out of the seams. And then the problem with this is that, let's say I want to scale horizontally a signaling server. Okay, so that's great. I shard the data, put 10,000 people on each and every server. But now how do I connect someone on this server to the server over there? How do I even know on which servers they are? So the complexity of the things that you need to start dealing with grows the moment you have more people. Now, you won't get to the signaling problem first. You'll hit first the problems with your media servers, because that one can do 100 sessions, 200 sessions, 1,000. That would be like the upper limit of most servers today.
Yeah.
And then they will crash and burn because, well, that's it. Now, before they do that, what happens is that they would start to lag behind and kill some of the sessions silently. So sessions are going to work, but they're going to get more packet losses, a bit more delays. a bit more problem with ordering, synchronization with audio and video, but you won't know that until someone complains, unless you're looking really closely on what's going on there. Okay, so that would be the main problems. If
So
you
yeah,
are
your
going,
media servers will do 4 or 5 sessions per core on an MCU and maybe 20 on an SFU. So yeah, you're right. It's probably far less than 1,000 people on a server.
yes, but the 1,000 comes from the people that say, well, it's a broadcast. There's one
Okay, yeah.
person sending, 1,000 receiving. I couldn't care less. I just take the media, pop it out there, and that's it. So then you can get to 1,000. Once you start dealing with, let's fine tune and tweak and see what each one of them needs and deal with packet losses in FIR messages, then it will be less than 1,000 as well. But
Yeah,
the
so
issue is that how do we even get to the point where you can call 100 friends and tell them, well, I need you all because we need to test the system.
yeah, that's
Okay.
a problem. I mean, we've done this at SignalWire, but there were 60 of us at the time, and there's just 60 of us. Like the servers stood that, but we don't know if we can stand more, for example.
You have another problem. There are 60 of you, but well, you're not on the same type of networks
No, at all.
and not on the same type of machine. So you and let's say you found a problem. Well, can I ask you for your WebRTC internals dump? Oh, but you forgot to create one for me, or you opened the tab too late, or you don't have one, or you don't know what that is. And well, now I need to get all 60 of you to come again 2 hours later because I fixed something and I want to check again. Okay.
Yeah.
So with WebRTC, the moment you start hitting large scale, especially with media servers, you need to have automation in place in order to make that work well for you. Otherwise, you're like screwed. How are you going to test that?
Yeah, you will never know if it works until it doesn't.
Yes.
Okay, so what would be the approach for someone just starting out, in your opinion? Like, what numbers will you look at? What's the best way to get started if, again, your application works, as you said, and going from there to a product you can actually have people use?
Yeah, so you need to test. That's obvious. And you need to test it systematically. Okay, so one thing that you need to do is to say, well, I'm going to test that, but I'm not going to rely on external people. I need a tool that will be able to do that for me. There are 2 types of tools on the market today. Okay, one of them are the tools that are based on browser automation. So they take Selenium or Puppeteer, they do something with that, and they send traffic from Chrome browsers or whatever browsers toward the service itself. This is the majority of the tools today. The best thing about them, well, they use browsers and your customers are going to use browsers, so they test the things that you actually need to test.
Yeah.
Okay. The problem with them is they are expensive because browsers take a lot of CPU, and then I need a lot of machines on the cloud in order to do that kind of a stress test.
I
So
know
it
I
doesn't matter.
built one, and
Yes.
it was useful mainly for feature testing. So you'd have take screenshots, etc. But it was very heavy. Like 10 sessions will kill a 4-core.
Yes. So we use 4 cores for 2 sessions only.
Yeah.
Just because of these things. And then you need to start scaling it, and you move from Selenium to Selenium Grid or whatever. So this is one set of tests, and testRTC is in that scenarios. Yes, this is what we do. The other option is to use tools that would automate traffic that is like synthetic in nature. I'm not going to encode data. I'm not going to use cameras. I'm not going to use browsers. I know what the media server is waiting for. So I'm just going to feed him with that data, and let's see when it is going to choke. Okay. That, for example, is what I think Jatak is doing for Janus. They have an internal tool at Mitaco that does exactly that. You can take one media server and try to repurpose it to just send garbage traffic to another media server, and then they just pass around data. And again, it works well, but the problem is that this is totally synthetic in nature. It doesn't come and say, well, let's start to see what happens if there is packet loss.
It will tell you if your server can stand a certain amount of traffic, but nothing else.
Yes, it won't check the behavior, the real behavior of users. And then if I would go through that route, which is cheaper, I would say, well, we go to 100. I'm not going to try more than 50 or 60 on such a machine. Because the number 100 that I get there, that's the number of sessions that I can do, is I would call it a theoretical maximum limit that my server will ever be able to get on that kind of a machine. Okay? And I'm not going to hit that theoretical limit because there are a lot of paths around the server that I'm not even trying or checking that are going to increase the CPU load on the server and are going to affect that number and bring it down.
Okay, yeah.
So I'm a bit worrisome from these types of numbers. They're too theoretical for me.
So you need to do both approaches and merge them?
Sometimes. In some cases, this is what we suggest to our customers, by the way, at testRTC. Sometimes they end up just using us, and it depends on the scenario. So let's say what I want to do is, I don't care about load, okay? Because I'm fine. What I want to check is how much a single machine can actually withstand.
Okay.
And if we said that bad single machine can get to 100 or 200, then that's like an easy use case for something like testRTC or for Selenium Grid. You take 100, 200, 400, 500 cores in the cloud, connect them and everything is fine. Then such a tool would be best. And then the question is, okay, now I've got one machine, but I need to check scale out. How do I do scale out? Well, you double the numbers or triple numbers and see what happens. And again, you end up being happy with the results. Then comes in the customer and says, well, I need 100,000 machines, or I need 100,000 browsers. So you say, well, it can't be done. Okay.
Because I only have 5 servers.
No, we run dynamically the servers in the cloud today on demand. I go, I ask Google, they give me machines, I'm fine, I'm happy. Now, the problem with that is that I cannot go and ask for 100,000 machines from Google.
They're just not there. Yeah, it's too many VMs.
Yes, and even if they are there, Google aren't going to give them to me because our quotas, just that's between you and me, are in the thousands of machines per data center. So if I take all of the available quota that we got from Google by working on their cloud for 7 years and being, good customers that pay well and run our loads, we can probably scrape out 50,000 cores maybe on a good day. And would they give it to us? I'm not sure.
No, probably not, because it will be really too much.
Yes, and last year we had Black Friday.
Yeah.
We had like the best and worst weeks just because before Black Friday. Somehow we had too many customers coming 2 weeks before Black Friday wanting to go to full capacity with our service. All of them at the same time. Yes, and it got to the point that we had a customer that said, well, I need 6,000 browsers. And that's like more than we can do. We said, okay, fine, let's go for it. Let's do it for you. We went to Google. We said, we need 6,000. They said, where? We said, East US. They came and said, no. We said, why? They said, because you want it near Black Friday and we don't have that capacity available. So if you want, we can give you 1,000 here, 1,000 there. And then we can might be able to approve. But after you get the quota, actually getting the machines is a different story because you might not have them. No, it takes minutes. But if they are available, they might not be there.
Oh yeah.
Okay. Now here's the funny thing: we came back to the customer and we said, yes, we can do 6,000, but not on that day, a day before. They said fine, and I told them, well, in order to get that number, we had to ask nicely, Google, go to your cloud provider and see that you can actually ask for these machines on your end that you need in order to run your service to be able to do 6,000 with us.
Because we're going to break it if not.
Yes, and they came back 2 days later and said, well, we're going to do 3,000.
No, they didn't have the nodes themselves, right?
Exactly. So,
well, 3,000 is, I don't know if it's an SFU and MCU, but might be anywhere. That's still short of 1,000 machines for them, something like that. So it's a lot.
I think that with an SFU, you can make do with 10 machines with 30, 40 cores each.
Oh yeah, well, still,
Sometimes you
it's a lot of it's 400 to 500 cores. It's a
yes.
lot to get overnight. Yeah, so they got told. Yeah, I mean everybody has the same thing. So you suggest going to with the testRTC route for your main testing, and then when your scale is a little bit bigger and you start noticing you need to really grow, go to synthetic traffic to really know that you can do 100,000 users.
So that's where companies stall and wait, and then they say, well, we have a problem. Okay, the first one is this. If I go to synthetic traffic, I need to do synthetic signaling on top of that traffic. Now I need to not only use the QA resources that I have, but I need developers to do that part.
Yeah,
Developers are
which is often more complicated.
yes, and I don't have developers available. And what am I testing? What the developers are writing, or the actual code that I'm trying to test? The end result is usually that you're not going to mix and match these things. Sometimes you do, but sometimes you'll say, well, I'm going to do the 10,000 or 100,000 browsers with something like browser stacks or with on new cloud-based API testing, and I'm going to check the signaling with ignoring the media altogether, just to see that all the other routes work well.
Okay.
So it's
It's
different type of approaches.
it's never simple. So say we are at the point where we've done some testing with testRTC and we're happy with having a few hundred people on the servers, and we know it's work. Now we know it works, as opposed to, as you said earlier, it works for me and you today testing. We are reasonably sure it will work for 100 to 200 300 people. That's the servers are all set. What else do we need? You mentioned stun and turn earlier. How important are stun and turn in a WebRTC setup?
Well, without them, it will not work.
Which is quite important in my book.
Yes, so you need to test them separately. My suggestion to almost any company that comes in and said, we're going to build things on our own, it's like, well, go use CPaaS. And when they say, well, it's too expensive, the next thing I tell them is go to Twilio. They have a service called Stun Turn. Buy that service, only that, nothing else. Instead of installing your own turn servers and then trying to figure out for a month or two how to configure that to actually work, and you know that it works and validate that it is working, just go use Twilio, and that's it.
And then you can scale out to your own solution whenever you.
And you'll find companies like Discord that up until today are using Twilio for stun and turn. But
there's another large company, I think it's called Sources, that has a very good stun and turn, has a very good stun and turn service.
Both of them do.
Yeah, it's I think I agree with that. And one last part, what the if we were to go, so now we solved the server side. Well, not solved, but we're happy with the server side. We're reasonably happy with the stun and turn situation. Is there anything to know about how to configure the clients? Because many times people complain about the clients being slow, ICE candidates being trickled slowly, etc. Is there a way, in your opinion, to make sure the user experience is good on the client and all you can do is really just test?
So again, it depends. If you're at the point in time where you know that there is a problem, and the problem is systematic to everyone or to a large group of users, then it's a problem on your end. And then you'll need to simply go, troubleshoot, find, optimize, whatever. Two very common problems, well, not using trickle ice. There is that. And then connectivity is going to be slow. The second very common problem is, well, I'm going to do a group call with an SFU, put 30 people on, and I'm not going to use simulcast. The moment you say that, well, you're going to kill my machine after the 5th person joining, because each one is going to ask me for 1 to 2 megabits per second. You're downstreaming to my machine anywhere between 10 to 20 megabits per second, which is great. If my network can eat that capacity, my CPU cannot decode so many bits.
Okay, I see. So beware of simulcast. Use simulcast right, not everywhere.
Yes, and all open source platforms provide a very good solution, but you will need to optimize for that. So they will support simulcast, but you need to choose which of the layers you are going to pick. They're not going to do it for you. They're not going to be intelligent. Okay, so they leave a lot to the developer to do all of these pick and choosing and optimization of how to build stuff to actually work and scale on a single call.
Okay.
So scaling a single call becomes also problematic. Okay, now assuming everything is fine, you've tested everything, and you know that your service works really, really well. You know that in your heart, you tested it, you know it, okay?
Well, you never really know, but you can be
Yes.
reasonably sure. People, we're engineers. We're never convinced that things really work until we see them in action. So
Yes, but
we
now
didn't
you
mention what?
yes. So now you need a slightly different mindset, okay? Things are working, we've got our DevOps team, we check everything, we test everything, we know that the platform is pristine and your use case should work as advertised. Okay? And now it doesn't.
Right.
Okay, now this happens to everyone. It doesn't matter which vendor you're going to go for, they have these problems.
And it's 3 a.m. on a Friday night.
It can be even 8 a.m. on a Monday. Okay? The problem is this. Now we have a customer is complaining, things don't work for me.
Okay. How do you find out?
Yes, and now help me. Things don't work. What are you going to ask for me to do?
I don't know.
So the two things that people usually ask is, well, send me a WebRTC internals dump.
Yeah.
That's going to be too complicated because, well, I'm a grandmother and you're asking me to open a new tab, open Chrome WebRTC internals, then do that before I start the session, leave that open, go back to that after 2 minutes, click a button, click download, take the file, put it in emails, and it's just too much work, okay? So one solution is, well, we're going to get all that metrics, look at our server side, and now we're all happy, okay? You're looking at your server side, and guess what you're going to see? There is packet loss.
Yeah.
Okay, so there is packet loss.
But knowing that doesn't really fix anything. Like once you know.
Yes, there is a problem. It's packet loss. Okay, so the next thing that you are going to probably do is you're going to tell me, the grandmother, well, go to speedtest.net, run a test, send me a screenshot.
She can do that, I think. She can get to speed test.
Yes, but now you asked me for two things. So we've got this, round robin. You're asking, I'm doing, you're asking, I'm doing, you're asking, I'm doing. So it's this back and forth, and it's now not 3 a.m., it's 5 a.m. already.
Yeah.
Because you need to wait for me to do the things that you've asked for and to send it back, and I sent it and it's not exactly what you wanted, or it's from a different machine, or now it works. And this happens all the time, this back and forth.
I've seen all of that.
Yes, exactly. I've been in voice over IP for the last 20 years. It's always like that. So you need a way to collect all the things that you need, and they're not things that are only of your service. It's also understanding what is the environment of your customer. Okay, because things that can affect the call, well, I'm using Wi-Fi on a poor network and I'm very far away from my access point.
That's gonna kill your any connectivity.
Yes, exactly. For me, I'm connected with fiber to the home on a wireline directly to the switch, and I'm the closest one, to the carrier today, because I know that it's important. This is what I do, and I even use wired headset because I hate everything that is wireless. Most users are not like that. It might be that, well, someone wanted to see Netflix on a different country.
Oh yeah, so they have a VPN now.
They installed the VPN, and now instead of going through the country that they thought they're going through somewhere else. Nothing is going to tell you that by looking at the metrics of your call.
Yeah, you don't know.
Yes. And
so
then
is there any solution to that?
Definitely. Well, barge into an open door. So we had a customer come to us 2 years ago. It was talk testing, and they said, we have this problem of customers, they can't do things, and we need to troubleshoot, and we go back and forth with them. And then I said, well, we don't have that. And they said, yes, we know you don't have that, but we want you to build it for us. So we build it for them.
Oh, nice.
It was a very good thing that we've done, because today we've got a lot of customers using that. It's a product that is called Quality RTC. Um, what we do there is we integrate with the backend of our client. So with the infrastructure that you have, your turn servers, your media servers, sometimes even the signaling part. And then we create a kind of a landing page that is white labeled to you and branded for you that you can send the customer. And that customer has only one thing to do there, and that's click the start button. It does that. This runs a battery of tests, collects all of the information, doing speed testing, connection to your service, checking the location of the user, trying to connect to the turn servers with different ways and mechanisms. And in the end, you get, as a support person, all of the data directly to you. You don't need to collect stuff, and the person doesn't need to send anything. You just get it in a few minutes' time.
So it sounds like what Quality RTC does is you effectively generate a test page for the customer's service that will connect to the customer's servers using the same signaling, etc., but actually do the measurements around it in the browser directly, and then ship them to whatever, so people can see what's going on without having to explain it. That is a very cool. That's a very cool thing. It's very
Yes.
very interesting. It's
Yes, and the nicest thing is that every time we have a customer that onboards, he asks for something that we don't have, and then we add that. So I had an interesting discussion yesterday, and he said, "Well, I want to know a bit more about the machine that is running it, because it's a video call, and sometimes because we do high quality 4K, it's a new, very unique use case. I need to know if he's using hardware encoding or not."
I see.
And we go like, okay. I can go grab that data and find information like the number of cores in the machine, maybe if a GPU is available or not. You know what? I can even go into the WebRTC metrics and find in there if the encoder and the decoder that have been used for the test that we're already running are hardware or software based. So
Which will
we're
make a
now,
lot of difference for sure.
yes. So now we're going to bubble that up into testRTC and enable that for all the customers that need it. So what happens is that the tool that started like a very simple tool of let's connect one call, see that everything is fine, go to speed test, has now become a tool that has a lot of different tests that are being conducted, and all of that information is provided. And a lot of the times that we're now spend in the thought process around the product is how to keep the dashboards very, very simple, so that it will be easy for a support person and even the user himself to look at the data and said, this is fine or this is not fine, and these are the things that I need to look at. So we're now in the problem of we're almost in the point of having too much information and needing to pick and choose what will work best for the problem that we're trying to solve for our users.
That's very interesting. It's I'd like to take a look at that, and I'll definitely go take a look after the podcast. And it sounds really, really like a good, well-rounded out approach that starts from the server and gets down to the client, which is also the path we took in discussing the various issues. There is one aside that I'd like to ask you, and also something maybe we need to clarify. We've been talking about MCUs and SFUs, which are the building blocks of WebRTC. Someone might not know the difference. An MCU mixes the video into one source and then distributes that video to all participants, while an SFU will send each participant's video flow to all of the others with various roles. But the simple explanation is like that. Then it can be. In your opinion, what's the pros and cons on on the two approaches from your point of view? Like from all the hours you've seen, what's the main pros and cons of both?
So an MCU is expensive compared to an SFU. It's like anywhere between 10 to 100 times more expensive to operate because you need more CPUs. It's also a bit less flexible in terms of how the UI ends up looking like, especially if you want to embed it into a third-party application. Because in my application, I've got a lot of things that need to go on. I need one video window here and the other video there. How do you do that with an MCU? With everything in between is unrelated to video. So this is the flexibility part. Now, an SFU is a lot harder to build, I think, today, at least. Because an MCU, well, we have it for the last 20, 30 years already. The problem space is quite known. And the solution there is almost always brute force. I'm going to put more CPU on that, and then I'm going to optimize after I do that. With an SFU, CPU is never the answer on the server side, and you're always in the point of let's optimize it to alleviate the CPU that I'm asking the client to use for that. Okay, this is why with an SFU today the upper limit is something like 30 or 49 participants in a call that you see everyone, whereas in an MCU, well, it's infinite because I'm throwing more hardware to the problem, but on the server side, so nobody cares. So that would be the main difference. And then there's this hidden aspect that every SFU needs an MCU.
For audio.
No.
Oh.
For recording. If I want to record the call.
You're right, yeah.
And I have 10 participants in the call, I need to mix all of their data. So even if all of them get different streams, at the end of the day, I need to take all of these streams, mix them together into one video that will be recorded and stored for posterity or whatever.
Yeah, so the
even
future is probably hybrid.
Yes, yes. So even when you have an SFU, a lot of the times the thought process there would be, well, now we need an MCU, what we're going to do, or we need to record the data or send it to YouTube Live or whatever. And at that point in time, what you happen to do is, well, there's FFmpeg and GStreamer, and you can use even FreeSwitch for that, or you can use something like Headless Chrome and have another browser join in, do the mixing for you because it's just another user, just nobody's going to see him, and record that out.
Yeah, I've seen that. I've also used FreeSwitch for the very same reason. Yes, it's a. So, will you say that in general, so video and WebRTC are equivalent in CPU resources needed? Only the MCU and the SFU shift the resources differently. Like most of the resources needed are on the server in MCU, and an SFU shifts more of the work on clients essentially.
Yes.
So, yes. Yeah. Someone's got to pay for those pixels.
Yep, and it's not going to me as a service provider. I don't like paying.
Yeah, so someone else has to do it. Yeah, it is. It's a very interesting discussion. Well, I mean, thank you very much. If you'd like to tell us more about your bloggeek.me hat, since we didn't go over that quickly, that will be a very good way to cap it off. Yes. What do you have on there? I was looking at there's all sorts of white papers, cheat sheets, and all stuff. So, but I'll let you explain because it's very interesting.
Yeah. So first of all, bloggeek.me, go subscribe, whatever, so you get my emails. I write articles about WebRTC every week or two, usually every 2 weeks, I hope. That's where I pour my thoughts into paper. The main driving force for that for me ends up being consulting. And people that go into the WebRTC course at webrtccourse.com, where I have courses there for developers and for support people that want to learn WebRTC. There are also a few ebooks there about scaling a server, and scaling a group call. Next month, in February, I'm doing a workshop around the trends of 2021 for WebRTC. Things like large group calling, background removal, noise suppression, AV1, VP9, and end-to-end encryption.
Wow, that sounds very interesting. Go sign up, people. It sounds really, really interesting. Well, I mean, thank you very much for joining us today. It was a great journey towards how to get your application that works for you and your friend towards something that you can actually have other people use and sell. We went through a lot, and I'm sure people will have questions. So feel free to drop either of us an email, and we'll be happy to guide you towards the right direction. And I want to thank Tsahi Levent-Levi for joining us today. Sorry, I mixed up the English pronunciation and the Italian one because Levi is a very common name here, but still. So Tsahi Levent-Levi for joining us here. Thank you very much. And maybe we'll see you in a while. I mean, that's sounds like there's a lot of interesting things going on. So maybe we can revisit in a few months. Thank you so much.
Thank you, Luca.